Hello, how is it going? I hope you're having a good day at school today. I am actually really sad I'm not there. I really actually do wish I were at school instead of stuck at home sick, but hopefully I will be back tomorrow. In the meantime though, I wanted to make a quick video tutorial so that way you can still keep learning and practicing math even if I'm not there. So we are going to be working today on how we can use systems of equations to apply them to solve word problems. In the real world, how do we use systems of equations? And so we'll be going through some examples in this video, and I'll explain the whole process to you as we near the end of our systems of equations unit. Soon we'll be moving on to a new topic, so we're starting to wrap it up now. Just so you kind of know what's coming up. Tomorrow I want to check in on elimination, so since I haven't been there the last day or so. So we're going to have a small daily quiz, just a daily quiz, the small little paper daily quiz about elimination where we have to multiply, so just so you know that's coming up. And then I'll just check in with you, talk to you about how today went with what this video is about when I come back, hopefully tomorrow. We'll see how you're doing and move forward from there. Here's an outline for how the day is going to go. To explain the work and to give you a chance to practice problems like this, I've decided to split the day up into two separate videos. The first video is this one that you are going through right now, where I will explain some examples. And then the second video is going to be on Edpuzzle, which is the site that we use for the bingo game where you have to type in your answers. So to start it off, I'll explain some examples, and what I'm going to say is this day, since I'm not there to monitor you and check in with you personally, it's a day for you to self-assess and think, do I understand this yet? Do I need a little more explanation? And so it's up to you to decide how many examples you will watch. So if you watch, let's say, 2 examples and you think you got it, then go ahead and go to Edpuzzle and work on the practice. If you, after a couple examples, are still thinking, okay, maybe I want to see a couple more, then keep watching more. You decide in this first part here how many examples you want to see to make sure that you're getting it. Then when you think you've got it, move on to Edpuzzle, which I posted the link on Google Classroom, and there will be 4 practice problems there. And the practice problems, you'll need to enter in your answers before you can move on to the next problem. But I also need to see your work, so you should be working on paper while going through the video. And then finally, at the end, if you have extra time, like always, work on mappers. It's a new week, so you have the time resets, new time that you need to get in for this week. Okay, so here's our first example of how we would use systems of equations in the real world. Let's take a look at this example together. Sarah bought a total of 8 cookies at H-E-B. She purchased both chocolate chip cookies and sugar cookies. She bought 2 more chocolate chip cookies than sugar cookies. She had a total of 8 cookies. How many chocolate chip cookies and sugar cookies did Sarah purchase? So in this problem, we have 2 things that we're trying to figure out. In order to figure out what the things are that we want to determine, we look back at the question, how many chocolate chip cookies and sugar cookies did Sarah purchase? What are the 2 things that we want to know? We want to know both how many chocolate chip cookies did she get and how many sugar cookies did she get. So in order to figure this out, we're going to be writing a system of equations. So in our system of equations, we need 2 variables. We need an x and a y. And so we are going to use our x and our y for the 2 things that we don't know. We want to know the number of chocolate chip cookies, and we want to know the number of sugar cookies. So in this scenario, the variables represent the 2 things we're trying to figure out that we do not know right now. Next, we're going to go back up to the problem, read it again, and represent the words using now equations instead. So back to the beginning, Sarah bought a total of 8 cookies at H-E-B. She purchased both chocolate chip cookies and sugar cookies. She bought 2 more chocolate chip cookies than sugar cookies. Okay, so I'm seeing chocolate chip cookies and sugar cookies now. So now that I'm representing chocolate chip cookies with an X and sugar cookies with a Y, I can change my chocolate chip cookies here. I can change this to an X, and sugar cookies, I can change this to a Y. So reading this sentence again, she bought 2 more X than Y. So in other words, whatever Y is, X is going to be 2 more. If she bought 2 more chocolate chip cookies than sugar cookies, let's say she got 8 chocolate chip cookies, then that would mean she got 2 more of those, so that means she only got 6 sugar cookies. So in order to figure out how many chocolate chip cookies she got, we need to add 2 to however many sugar cookies she got. X is 2 more than Y. So we're at 2 more tells me we're adding 2 to the Y. Let's continue reading this. She had a total of 8 cookies. So I don't know exactly how many sugar cookies and chocolate chip cookies she got, but I know that the total all together adds up to be 8 cookies. So however many chocolate chip cookies she got, plus however many sugar cookies she got, all together equals 8 total cookies. So these are our 2 equations. It's our system of equations that we're going to solve to see what is our X and our Y. How many of each type of cookie did she get? So in order to solve this, we could use substitution or elimination, but let's check to see which one might make more sense in this situation. So for elimination, we need to have equations, an X and a Y equals a number, an X and a Y equals a number. The X and the Y need to be stacked up right on top of each other. Here in this scenario, they're not. So elimination might not be the best in this scenario. For substitution, what we need is to have a variable alone, either an X or a Y. And when I'm looking at this system here, I see that this X is completely alone. So what I can do is solve this system using substitution. So I'll substitute this for X in our second equation. So instead of X, I'll put 2 plus Y equals 8. So I substituted this amount for X here instead. Now I'll solve this. So I'm adding Y to all of this. So if I'm adding it, I can combine the Y's, a Y plus a Y. That would be 2 Y's equals 8. I'll continue to solve this. 2Y equals 6. I'm going to move this up over here now for some more space. Divide by 2. So Y equals 3. So we know that she got 3 sugar cookies. Now the last step is I want to know how many chocolate chip cookies did she get. So now X equals, we want to know how many chocolate chip. Instead of 2 plus Y, this is the equation I'm using from over here. We already know X equals 2 plus Y, but now instead of Y, we can substitute that Y for a 3. So X equals 2 plus 3. So X is 5. She got 5 chocolate chip cookies. So our final answer is 5, 3, or 5 chocolate chip cookies and 3 sugar cookies. Let's move on to another example now. This one will have a very similar way of solving that we did in the previous example, but I'm going to show you a slightly different method for solving the system. Anyway, the first step though always is to read the problem. Lucas has an insect collection that contains only ants and beetles. On Tuesday, Lucas did not have much luck finding insects to add to his collection. The number of ants plus twice the number of beetles was only 8. The difference between the number of ants and beetles was -4. How many ants and beetles did he catch? Our first step always is to define our x and our y. So that's the very first thing we do when we're solving these word problems like this. We want to know, what does x represent and what does y represent? And in order to figure this out, we want to know, what are our two unknowns? What are the two things we're trying to figure out? And we can determine this usually by looking back to the question at the very end of the word problem. So looking back at this question, how many ants and beetles did he catch? Okay, well, there's the two things that we want to know. How many ants did he catch and how many beetles did he catch? So we can fill in those two things here, the number of ants and the number of beetles. Then we go back into the word problem. Once we've defined our two variables, the x and y, we go back to the word problem and figure out what are our two equations based on any keywords we see and replacing ants and beetles with x and y. So let's go back to the beginning. Lucas has an insect collection that contains only ants and beetles. On Tuesday, Lucas did not have much luck finding insects to add to his collection. The number of ants plus twice the number of beetles was only 8. Okay, so in this sentence here, I'm seeing some numbers, I'm seeing some keywords like plus, twice. That's a key for me there, that this is the sentence that's going to help us with one of our equations. So let's go back and read this again. The number of ants plus twice the number of beetles was only 8. So the number of ants, we know we can represent that with an x now. Plus, I know this means add. Twice, I know this means 2 times. The number of beetles, I know now that this is y, was only 8. So was or is, that means equals. This is hopefully jogging your memory. We did this back in September, October, where we represented words, written words with equations. So there's the same keywords we're using now. So let's take this jumbled mess and write it as an equation down here. So we have the number of ants is x plus twice the number of beetles, or 2 times y, was only 8. So it was only 8. It equaled 8. Okay, there's our first equation. Continuing on, the difference between the number of ants and beetles was -4. All right, I'm seeing a key word here, difference. I remember that this word means subtraction. So the difference between the number of ants, so x, and beetles, y, was means equals -4. So rewriting this down below here, the difference between x and y, so that means I'm going to subtract x minus y, was -4. So there's our two equations, our system, and this is what we're going to solve. So I can use either substitution or elimination. Substitution works really well for a problem like the one on the slide before, where we had a variable alone. In this example, neither the x nor the y in both equations is completely by itself on one side of the equal sign. So let's see if we can use elimination. In elimination, everything needs to line up. The x's, the add or subtract, the y's, the equal sign, the number. Yes, it all lines up. So elimination is what we could use to solve this system. So in order to use elimination, I need one of the variables to cancel. So they need to be exact opposites, either the x or the y. Well, positive x, that doesn't cancel. Positive 2y, negative y, that doesn't cancel either. So I'm going to have to multiply one of my equations. I think I'm going to try to cancel the x's, let's say. So I need to multiply one of my equations times -1. So then I get negative x plus y equals positive 4. Done with this one. Now when I add them, x plus negative x cancels. 2y plus y, 3y. 8 plus 4, 12. So y equals 4. Then we can use any of these equations here to substitute this 4 for the y. I'll just use the first one. So x plus 2y equals 8. But instead of y, we can put 4. Then I will continue to solve this. Oops. There we go. So our solution is 0, 4, or in other words, 0 ants and 4 beetles. So in the end, you need two things. You need a solution as an x, y, and you need to write it with your labels. So in the context of this problem, what answers this question? How many ants and beetles did he catch? He caught 0 ants and 4 beetles. All right, I'm going to go through another example. Remember, if you feel like you understand the process of how to do this, feel free to start the practice. This example will help you as well on the homework. There's an example very similar to this. So feel free to keep watching. Absolutely, I'll go through a couple more examples just to make sure that you get it. So this example, we start off by reading the problem. The difference between two numbers is 6. The sum of twice the first number and the second number is 18. What are the two numbers? So remember, we first need to define our x and our y. We need to say, what does x represent and what does y represent? So in order to figure out our two unknowns, we go back to the question at the end. What are the two numbers? So what are the two things that we do not know that we are trying to figure out? The two numbers. So we want to know what is the first number and what is the second number. We want to know the value of these two mystery numbers. Now let's go back and read the problem again and see what our equations would be that would represent this scenario. So the difference between two numbers is 6. So I'm seeing a key word here, difference, so that's telling me that this sentence here will be one equation. So let's replace these keywords with symbols instead. The difference, I know that this represents subtraction, so I'm going to be doing some subtraction between the two numbers. So we have our two numbers are x and y. Is means equals and then 6. So the difference between x and y means I'm going to be subtracting x and y, meaning x minus y is or equals 6. Let's go to the next sentence. The sum of twice the first number and the second number is 18. So I'm seeing more keywords here. Let's go back and replace with symbols. The sum I know means adding, of twice I know represents 2 times. The first number is x, and the second number is y, means equals, and 18. So the sum of 2 times x and y. So I'm going to be adding 2 times x and y. So 2 times x plus y, the sum here of twice the first number and the second number is or equals 18. So then let's see what would make more sense here for solving this system, elimination or substitution. Do we have a variable completely on its own here? No. So maybe substitution isn't the way to go. let's see, our x's lined up, plus and minus, y equal, number, yes, everything is lined up, so we can use elimination. That is the method I would recommend. Now, if we're going to use elimination, that means either the x's or the y's should cancel when we add the two equations together. So looking at our x's, positive x, positive 2x, no, that doesn't cancel. Minus y plus y, yes, that cancels. So I don't have to do any multiplying here. I can just add these exactly as they are since the y's cancel. X plus 2x is 3x's. The y's canceled. 6 plus 18 is 24. So then we solve this. So x is 8, meaning the first number is 8. Then we use any of these equations. I'll pick the first one, but I'll replace the x with an 8. And canceling out the 8. Negative y equals negative 2. So I'll divide by negative 1. Y equals 2. So our solution is 8, 2, or putting it in the context of the problem, 8 is the first number, and 2 is the second number. Okay, I'm going to go over one more example now in this video. After this example, if you're still feeling like you might want some more help with this, you can check out Khan Academy. They have plenty of video tutorials and examples on how we can apply systems of equations to word problems like this. So let's take a look at this final example here. Fred is trying to figure out the age of two cousins. He knows that if he multiplies the age of the first cousin by 3 and adds 1, he gets the age of the second cousin. He also knows that the age of the first cousin is 1/4 of the age of the second cousin. How old are the two cousins? First step, always our first step. We need to know what does x equal and what does y equal. So in order to figure this out, we go back to our question at the end of the word problem. How old are the two cousins? And we think about what are the two things that we do not know that we're trying to solve. We do not know the age of the two cousins. So x can be the age of the first cousin, and y can be the age of the second cousin. Once we have our x and our y defined, we're going to go back to the beginning of the word problem, read it again, and see what we can represent with an equation. Fred is trying to figure out the age of two cousins. Okay, I see no keywords in that sentence. He knows that if he multiplies the age of the first cousin by 3 and adds 1, he gets the age of the second cousin. All right, I'm seeing some keywords. Multiplies, 3 adds 1. So this is going to be a sentence that we could represent with an equation. So going back to the beginning of this sentence, he knows that if he multiplies, so we're going to be using multiplication, the age of the first cousin. Well, we know the age of the first cousin now. We're calling this x. If he multiplies that x by 3, and adds, so addition, 1, he gets the age of the second cousin. The age of the second cousin we are now calling y. So representing this sentence with an equation would look something like this. So he multiplies the age of the first cousin by 3. So he's multiplying x times 3. X times 3, I could just write that as 3x. And he's adding 1. And it gets him, or it equals, the age of the second cousin, or y. Next sentence. He also knows that the age of the first cousin is 1/4 of the age of the second cousin. Okay, I'm seeing these words in here again, first cousin, second cousin, a number 1/4. So this will be the other sentence we turn into an equation. The age of the first cousin we're calling x. The age of the second cousin we are calling y. And let's see how we can represent this. So the age of the first cousin is, I also know that this means equals 1/4 of. When I'm talking about fractions, of has a special meaning. Maybe you remember that of means times. So in this example here, the age of the first cousin is 1/4 of, or times, the age of the second cousin, or y. So now we have our two equations. Let's decide if we should use substitution or elimination to solve this system of equations. So we've used elimination the last two examples. Let's see if we can use it in this example. Our x's, plus and minus, y, equals, numbers should all be lined up. X's, yes. No. Okay, no, no. The equals are not even close to being in the same place. The x and the y aren't even on the same side of the equal sign. They need to be on the same side. So elimination is just not going to work for this example. We'd have to really move some things around. There's probably an easier way to solve this one. And that would be with substitution, because I'm noticing that in this first equation, this y is completely alone. And in the second equation, this x is completely alone. So we can either substitute this for x in the other equation, or we could substitute this for y in our second equation. Either way, it will work out the same in the end. It doesn't matter which one you pick. I'm just going to pick to substitute for the y. So instead of y, I will put what y equals, which is 3x minus 1. So I'll rewrite that second equation. X equals 1/4 times, then instead of y, we can put 3x plus 1. All right, so I need to use the distributive property because I'm multiplying a number on the outside times parentheses. So we'll use the distributive property here to simplify this. X equals 1/4 times 3 wholes, I'll rewrite this over here, is 3/4. X plus 1/4 times 1. Well, I know anything times 1 is just that number. So there's our equation. Next, I'm going to simplify this. So I have one term on this side, two terms on this side. I want to have 1 and 1, so I'm going to bring one of these terms over to the other side. I'm going to cancel it here and transfer it over here. So let's see which one I should cancel. For example, if I wanted to cancel the plus 1/4 with the minus 1/4, can I do just an x minus just a 1/4? No, I cannot combine them. So that should not be my first option. Instead, what I could do is minus 3/4 x minus 3/4 x, because if I have x and x, now I can combine these. So continuing with this, this cancels. Here, I'm going to put this imaginary 1 in there. So now I'm going to do 1x minus 3/4 x. So 1 minus 3/4. I need to find a common denominator, so I'll multiply this times 4. So 1x minus 3/4 x is 1/4 x equals positive 1/4. I'm going to take this and rewrite it up here for some more space. So now I'm multiplying these two. So to cancel it, I will divide by 1/4. X equals 1/4 divided by 1/4. Well, anything divided by itself equals 1. So x equals 1. The last step is I want to know y. So right now, I know that y equals 3x plus 1. So instead of x, I can put 1. And I'm just going to go ahead and simplify this. So x equals 4. So our final answer is 1, 4, or the first cousin is 1 year old, and the second cousin is 4 years old.